Well, hello C++ programmers and fellow game developers. Brian Malloy here. And the animation you see in front of you contains the mighty Red Baron airplane chasing a crow. Or is it the crow chasing the airplane? I'm not sure which. I guess it depends on which iteration of this you're looking at. This discussion is a two-part series where I want to talk about explosions. And so first of all, I want to talk about the two kinds of, or the two techniques for making an explosion. So let me just hit an X and I'll chunk the plane. Okay, so that's a kind of chunking explosion. And now I'll do the crow, and you can see that's a different kind of explosion. So let me just show you the difference between the two. In the plane example, so for example, let me just wait till it comes around again. So I'm going to chunk the plane and pause it. So what's happening here? So what I've done is I've taken the image of the plane, the sprite, the SDL surface actually, and I've carved it into a grid. So I've drawn horizontal lines and vertical lines, and I've taken each of those chunks of sprite and I've made them into a sprite on their own right, and then I've given them each a velocity and a direction. Of course, velocity includes direction and position, and sent them off into outer space. So let me unpause this and you'll see that those chunks disperse. Let me do it again because I want to point something out with that. So watch. Now, I'm going to pause this again. Now this time when I let go, watch how these chunks, they go a certain distance, and once they get a certain distance away, they disappear. And that's the chunk reclamation part. So we want to be able to manage all of these chunks, all of this memory being dispersed. So you'll see, I'm going to unpause this and you'll see them as they disperse, they disappear. And that's a key idea with regard to explosions, chunking, and particle systems. How do we reclaim the memory and don't chew it all up and throw it away? So that's a chunking approach. And let me just do the crow now. So if I do the crow, that's simply a sequence of frames, and that's probably about 5 or 7 frames. I'll do it again. It's cute. I mean, they're both explosions. Add a nice dramatic effect. I would say that the chunking idea will work for anything. So you can take any sprite and chunk it. I can even chunk the crow. So, but it doesn't look quite as good with the crow, because it's like a crow. How come a crow chunks? The frames might work better with that. I'm not trying to promote either technique, and there are other kinds of techniques for doing this, but I want to familiarize you today with one of these techniques, and that's the chunks. Okay, so let's go with it. All right, let's get rid of this and let's look at a little class diagram. So the discussion today is going to focus on the explosion part. And so that's part 1. Part 2, I'm going to show you how we can perform this explosion in an object-oriented way. How we get a sprite to explode itself. That's the idea. We want the sprite, a class should take care of itself, manage its own memory, do its own thing, and it should just follow the commands we tell it. So that's part 2. So let's stick to part 1. So here's an explosion. Pretty simple, really. I have a base class drawable. I hope you're familiar with that. And it's it has pure virtual functions, draw and update, so we can be assured that any class derived from drawable knows how to draw itself and update itself. And it has some data attributes that we can reuse in all the derived classes. Like what? Well, its velocity, its position, and its name, so we can look up constants and attributes of this particular drawable in the XML. And we'll look them up in the XML file based on the drawable's name. And sprite derives from drawable, and it of course implements draw and update. And exploding sprite and chunk also derive from sprite. So an exploding sprite is a sprite. It's a whole bunch of sprites. It's a collection. So this is the UML symbol for an aggregation. So exploding sprites are aggregations of chunks. And so what we have in here is a list or a vector, probably a list of chunks. And if you look up the composite design pattern, this is real close, but not quite the composite. So it's close to a composite. So sometimes we can understand things by comparing and contrasting. And you might want to compare and contrast this inheritance hierarchy here with the composite design pattern. It might be an interesting comparison, and you'll learn something about the composite. Okay, so that's what we're going to look at right now. We're going to look at these really 3 classes, but mostly drilling down on these 2, how we do an explosion. So let me get rid of this, and let me start off with just the sprite class, because it contains some things that are portents of part 2 of this lecture. So let me go and get sprite. So here's the sprite class. Okay, notice we do a forward declaration of an exploding sprite. I can't remember why because, and we'll talk about this in part 2, one of the things that a sprite's going to contain is an explosion, because I want to tell it to explode. So I want to say to a sprite, go explode yourself. And it should know how to explode itself. Okay, so I wanted to show you that. Other than that, I don't know that there's much interesting here. So that's the sprite, and I've just kind of dipped into part 2 of this series. So let's go back to part 1. We looked at the sprite. Now let's look at the exploding sprite and the chunk. Okay, now actually all of this is coming from this example. So this is like a bait and switch. I showed you the first example just to demonstrate the 2 techniques for doing explosions. This one is all chunking, and I'm going to make this one available. I'll put a download link in the description for this video, and you can download this, compile it, and run it and play around with it. I have actually made the viewport almost the same size as the world so we can see these explosions. Okay, let me just do an explosion. There's one explosion. I'm going to explode the, what did I just explode? Let me do the yellow star. I think that's, well, I'm not doing too well here, am I? Let me try I just exploded the green one. I can't get this. Okay, finally I got the yellow. I was trying to get that yellow star. Let's do the spin. I'll do the green orb. Okay, so that's an explosion. Let me try 1. I think, let me do 0. Okay, 0 gets that. I want to get that yellow star again. Okay, now that's a way of doing an explosion. There are lots of ways to do these and disperse these things, much better ways, and I might show you one or a bunch of them later, but let's just talk about how we do this. So let's now go to a chunk. Let's see what a chunk is, and I've tried to give you kind of an insight into what to expect there, but there's not much to a chunk. A chunk is a sprite. Basically, a chunk is a sprite. What does a chunk have that a sprite doesn't have? So remember, derived classes extend the base class. So a chunk definitely is a sprite, but it's a little more than a sprite. What is it? How does it specialize sprite? It has this notion of distance. And I've already given you an insight into why we're keeping track of distance for chunks. So we don't want to, typically I'm not keeping track of distance for sprites, but I want to keep track of it for chunk. And the reason is I want to reclaim a chunk once it's gone too far. I want to stop drawing it, and I want to deal with it. So really, the only thing different between a chunk and a sprite is this notion of distance. So here's the constructor. Let me see, the constructor is right. Here is the constructor, and we want this conversion constructor to be an explicit call. We initialize distance to 0. We say it's gone too far to false. And essentially I have this little Boolean function. Did the chunk go too far? If the chunk went too far, I'm going to reclaim it. So the the implementation, that's the header. Here's the implementation. All we do is compute our y increment, compute our x increment. Actually, these should be added. I thought I changed that. And so we add the increment to the y position and the x position, and then we compute the distance that it traveled in this iteration. And that distance will be, we're using the Pythagorean theorem. So we find the x increment, the y increment, we square them, take the square root, and that's the Pythagorean theorem. Only this little function, hypot, will compute that. And I add that to the distance I've computed so far. Remember, we initialized that to 0 up here. And we've got a reset also, but there we initialize it to 0. And then we check. If distance is bigger than our max distance, which I'm hoping we read from the XML, we did. There's max distance. I'm reading it from the XML. If that distance we've computed right here is already greater than max distance, then we set too far to true, so that then my exploding sprite, which is an aggregation, let me just show you the UML diagram again. An exploding sprite is an aggregation of chunks. That means a collection. So let's see how we do that. So let me just make this a little bigger. I hope you can see all this. No, I'm sorry, that's Sprite. Let me get rid of Sprite so I'm not tempted to look at that. We want to look at an exploding Sprite. An exploding Sprite is also a Sprite. Actually, it's a bunch of Sprites. So what have we got? We've got a list of chunks and a free list. And we put something in the free list when we put a chunk in the free list when it went too far. Now notice these aren't pointers, so we're going to be suffering copy constructors, so you might want to change these to pointers. I'm just doing a little demonstration of it right here. And these are the frames. I might want to save the frames for an explosion so I can reuse them. Now you might want to use the factory to do all this. I don't know. I'm doing it right here though. So I can keep track of these frames so that if I wanted to reuse an explosion, it would be an easy thing to do. And I'm going to talk about that in part 2. So really, an exploding Sprite is just a collection of chunks. So there's not much to it. Let's just take a look. I mean, you probably already know, here's my destructor, but when I draw, I simply draw the chunks. So when I do a draw, I run through my list of chunks. Okay, there's my list of chunks. And so I set it to chunks.begin, and I just run through and tell them to go draw themselves. The update's a little more interesting. I also run through the list of chunks, and I tell the chunk to update itself. So I'm really calling the update over in chunk, which is probably the yeah, we looked at that update. This draw is straight from Sprite, but this update does a little bit more because remember it computes that distance for us, and then we check: did this chunk go too far? If that chunk went too far, I first put it into the free list, and then I take it out of the chunks list. Notice that I'm so careful about erasing. When you erase something from a list or vector, the iterator is invalid. However, this function will return an iterator that points to the next item in the list, so that's how I update my pointer if I erase. Otherwise, I simply increment it. So that's the draw and the update. And other than that, we just got to figure out how to make the chunks. And here I'm making them. All I do is find out what the width and height of the frame is that I'm going to take it and make it into a grid. And each of these squares in the grid are going to be chunks. So then I compute the chunk width. So I've got the frame width. There's the frame width. I want to divide it by the chunk width, and I want to have that width be at least 1. So I take the max of either 1 or whatever this is. Hopefully that'll be greater than 1. If it's 0, then each chunk, the smallest chunk is going to be 1 because we want to draw something and not get a segfault. We compute the height, and then I compute a speed. Here, this isn't the best way to do it. I can show you lots of different ways to do this. And essentially all I do, excuse me, is have a nested loop where I run across the rows and down the columns and just compute chunks. And I make a frame, put the frame in my list later down here. So there's my frames list. I put the chunk in my chunk list, and I simply update everything here. And excuse me, the tricky thing is to compute the new velocity in the x and y direction for the chunk. This is kind of just a brute force method where I get a random number between 0 and 1, and if it's a 0, then I multiply by 1. If it's a 1, I multiply by -1, and then I just get this little speed value, so it goes off in some random direction. I don't know if you like the way it looked. Let me just show you. I think that pretty much covers it, but if we run this, let me bring it back and I'll show you what these chunks look like. I'm going to do the yellow star, I'll do the green one, and there's the spinning star. Now a big question might be, how do I do a multi-frame sprite, which that is? Well, that's easy. I just get the frame I want to explode, and I chunk that baby right there. Let me just show you a better explosion. See if you like this one. I don't know if you like. Here's a different look at it. Let me show you. Here's the, let me see if there's the yellow star. Did you like it better that way? I don't know. Let me show you the green. Wait till the green orbs comes back. I don't know if you like that any better. That's how you can do explosions and chunks. I hope that was informative. And so all I can say is happy programming and even more happy gaming. Brian Malloy over and out.